For okay, let's. I have given you some assignment. Have you done the questions from that assignment regarding to the balancing of chemical equations? Did you do that one?
Sir,
Tell me.
I'm not clear with balancing the equations. Can you please explain it?
Yeah, okay, why not? Just a minute. Let me have that assignment. Just give me a second, okay? And the assignment, another assignment was also given to you. Did you know how to write the chemical formula of the compound? Did we learn that one also? How to write the chemical formula of the compound? Just tell me honestly, did we learn this one? That will you be able to write the proper formula for this compound? Yes or no? Okay, honestly tell me what is the formula for the aluminium sulfate? Aluminium
Al2SO4.
sulfate, Al2SO4.
Yes, sir.
No,
No,
Al2
Al2
SO4 3,
whole thrice.
the whole
Okay.
thrice.
What is the formula for the ammonium nitrate? What is the formula for the ammonium nitrate? Nobody knows. Okay. So
Sir,
today, yes,
NH4NO3.
NH4NO3. The other students, Jaina, is Aisha is correct? Tell me yes or no. Mariam, is Aisha is correct?
Sir, 1 minute.
1 minute. It means you are not sure. So let's you write first you let you learn that how to write the chemical formula of the compound, and then we shall be proceeding towards. Okay. Here is that we need to learn that there is a valency chart. Okay, there is a valency chart, and according to that we have to write the chemical formula of the compound. Okay, there is a valency chart. So this valency chart, first of all, copy this valency chart in your notebook. Okay, so that you can learn how to write the proper chemical formula of the compound. If you don't know how to write the chemical formula of the compound, then you will not be able to copy. You will not be
Sir,
able
was
to
I
learn.
correct or was I wrong?
You was correct. NH4, NH4OH. You told
Okay.
NH4OH.
Yes, sir. NH4NO3.
Okay, what is the formula for the ferric oxide? Ferric oxide. Ferric oxide.
FeO2.
It will be
FeO3.
no. It is Fe2O3. F when iron has two valency. When it
Okay.
has two, it is known as ferrous. Ferrous. Okay. And when iron has
Okay.
three valency, it is known as
Ferric.
ferric. Ferric. Ferric. Okay. And when, like for example, if I'm saying copper has +1 and +2 valency. So the lesser one is known as cuprous, cuprous. Okay, and the greater one is known as cupric. Similarly, iron has +2 and +3. So greater one is known as ferric, and the lesser one is known as ferrous. Okay,
Okay. Okay.
okay. So please try to note down this valency chart. This all that I've made in the square, that is all having +1 valency. And sometimes they mentioned here like this way, copper, they will write it copper 1 and then sulfide. So it means it is copper sulfide they are talking about. Okay, and this written copper 2, it means they have taken the valency of copper as 2. Okay, so sometimes it is written like this way. This I have written here iron 3 and it is ferric. So please note it down. I with the green sign I represent here that it is sulfide IDE, it is sulfide ITE, and it is sulfate. They all have different formulas. It is only S minus 2, valency is minus 2. Is it SO3? Valency is also minus 2. It is SO4, valency is minus 2. All of them are having the similar valency. Okay. But here in this case,
Okay, sir.
nitride and nitrate has different valency. Nitrate has minus 1 and nitride has minus 3. Okay. So please note it down honestly in your copy. You done?
No, sir.
Sir.
Note it. Note it. Note it. Note it properly. Okay. Done. Write down this one also. Abdul Jabbar, are you there in the class? Abdul Jabbar, other students? Yes,
Yes,
sir.
sir.
You done, everybody? Write down this one also. Barium has two valency. It is not written. Barium. Then beryllium is Be2 positive. Mercury is Hg2 positive. Lead is 2 positive. Pb2 positive. Note it all, please.
Okay, sir.
Sir, done.
Done? Okay. Okay. So here, if I ask you to write the formula of the compounds, okay? Like here, if I'm asking you to write the formula of the following compounds, that is being given here, okay? So, everyone knows that in the ninth class you study that, for example, if you need to write down the formula of sodium sulfate, aluminum. So, aluminum has three valency. You can check it here. Aluminum is three here. This is aluminum. And sulfate is SO4 and its valency is -2. Okay. So, you can write these formulas like this way. Okay. So, aluminum sulfate. The sulfate has valency 2. Don't write the plus and minus sign, just cross multiply these two. You will get Al2SO4. And when it is a polyatomic ion, means more than one atom, sulfur and oxygen atoms are present. So you have to write it in the brackets. Like for example, if it is sodium oxide only, Na has valency 1 and O has 2. So you cross multiply this one and you will get Na2O. But if you have magnesium or aluminium oxide, aluminium has 3 and oxide has 2. So then you can write it like this way, Al2O3. No need to write it in the bracket because it is a single element here. But if it is like sulfur and oxygen, so they are the two elements. So when you are going to write it, you have to write the polyatomic ion in brackets. Like for example, calcium hydroxide. Calcium has valency 2 and hydroxide ion has 1. So you cross multiply, you will get Ca. Don't multiply 1 here. Don't write 1. Okay. So it will be CaOH whole twice. When you are going to write the formula, when some elements have same mean positive and negative have both same values, like calcium has 2 and sulfate has 2. So no need to cross multiply, just cut it and you will get the formula CaSO4. Okay. Okay,
Okay,
everybody.
sir.
Yes, sir.
So please write down the formula with the help of table. Write down the formula of the following compounds. Aluminium sulfate I have done. Sodium oxide I have done. Calcium carbonate, and this up to this elements too. This one, 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 this one. All of them. Do it. Write down the formula of the compound. Are you doing?
Yes, sir.
Yes, sir.
Okay. So here is calcium carbonate. Done? Tell me. Is it done or not?
Yes, sir.
Yes, sir.
What's the formula?
CaCO3.
Ca has two valency and carbonate also has two valency. So you can check it here in the table. Calcium, where is calcium? Calcium has two and carbonate also has two. So they both will cancel out each other and you will have the formula CaCO3. You cut it, you will get CaCO3. Similarly, aluminium nitride,
ALN.
ALN. ALN, because nitride, IDE, this is IDE, nitride. It has three and aluminium also has three. You cut it, you will get Al and three. This is nitride. Okay. You understood, everybody?
Yes, sir.
Then the formula of sodium sulfate, sodium phosphate,
Na3PO4.
Na3PO4. Yeah, it will be Na3PO4 because phosphate ion has one valency. So it will, three valency, it will cross multiply here and sodium has one. What is the formula of zinc carbonate?
ZnCO3.
Hey, Mariam, let the other student also speak. Okay. I know you are doing very good because you are studying here with us in the ninth standard. Okay. Proud of you. Yes, Aisha, do you know what is the formula of the
Yes,
zinc
sir. ZnCO3.
ZnCO3? ZnCO3. Yes, Gianna, what is the formula of barium sulfate? What can be the
Sir.
formula? Yeah. What is the formula for the barium sulfate?
Sir, Ba.
Okay.
Sir,
Barium. Barium has two.
BASO.
Yeah.
BASO3.
No, BaSO4.
It's
Barium has two.
SO4. Sorry.
Yeah, BsSO4. They both have two valency. They will cross out each other and you will get BsO4. Okay. Ammonium hydroxide. Ammonium hydroxide. Yes. Who is going to tell me? Abdul Jabbar. What's the answer of ammonium hydroxide? Abdul Jabbar, you used to answer always in the chat. Is your mic is still not working from the last years? Why it is so? You are not able to ask your doubt properly without of the mic. Okay. Yes, Aisha. What is the formula for the ammonium hydroxide? Ammonium hydroxide. Yes, you. Yes,
Sir,
you.
NH.
Yeah.
Sir,
What is? Yeah, speak. NH. What? Yes, Gianna. Aisha, tell me. You were saying something. NH what? Okay, Mariam, tell me now. What's the formula of ammonium hydroxide?
NaOH4.
NHOH4.
Ammonium hydroxide.
What is
No.
ammonium?
NH. No. NH4 1 plus.
NH4.
NH4. No.
Yeah. NH4OH.
Yes, sir.
NH4 is ammonium ion. It has valency 1. And OH is hydroxide ion, which is also -1. So +1 and -1 cancel out, you will get NH4OH. Okay. Ammonium hydroxide.
Yes. Yes, sir.
What's the formula for the calcium phosphate?
sir.
Calcium phosphate.
Sir,
Yes, sir.
Ca3PO4 the whole twice.
Yes, it will be this one. Calcium phosphate is written here. Ca3PO4 whole twice. Why? Because calcium has valency 2 and phosphate has valency 3. So this will cross multiply. This 3 will comes here and this 2 will goes in the bracket. Okay. So Ca3PO4 whole twice. Okay. Understood? Note down the formula properly. The formula is Ca3PO4 whole twice. Ca3PO4 whole twice. What is the formula of calcium carbonate? We did this one. Okay. Upload. Okay. Tell me the formula of calcium sulfate. Calcium sulfate. Formula for the calcium sulfate.
CaSO4.
CaSO4. Yes, it will be calcium sulfate. Both has 2 valency. CaSO4. Okay. Formula for the lead nitrate.
Okay, sir. Sir, PbNO3 the whole twice.
PbNO3 whole twice. Zinc chloride.
Sir, ZnCl.
ZnCl2.
Yes,
Lead
sir.
oxide. Lead oxide. Lead has valency 2 and oxide has valency 2. They will cancel out each other. You will get PbO. Sodium hydroxide. Tell me sodium hydroxide. What is the it is a very common salt that is used in your it is also called table salt.
Sir,
NaOH.
NaOH.
NaOH. Yes, it will
OH.
be yes, it will be NaOH. NaOH. Okay. Now I'm just giving you the word equations here that I was just explaining in the starting. Okay, and please try to do that one. Okay, just a minute. Okay, these are the word equations in front of you. Please write these equation in the chemical formulas. Write these equation the chemical formulas first. You have 5 minutes to solve all these. Do it. It's your time start now. Carbon dioxide, when heated, it will give you calcium carbonate plus water. Oh no, the first question start from here. Calcium hydroxide plus carbon dioxide will give you calcium carbonate. Means it start from here. Start from here. You done? Tell me fast. What is calcium hydroxide plus carbon dioxide will gives you calcium carbonate in water. So I'm just helping you. I will give you some of them in the homework. Just write this one, this one, this one, and this one. Write only 4. And the rest you have to write in the homework. We'll provide you the homework. Okay, do it now, fast.
Okay, sir.
If the copper chloride is given to you, like here copper chloride is given to you and it is not mentioned that it is the copper with valency 1 or valency 2, because it is not written like cuprous or cupric. If it is written like cuprous, cupric, then we can understood that if it is us, it is 1. If it is 2, it is ik in case of copper. But since it is not written here, so what we will write, we will assume when it is written only copper, then we write it only Cu. Okay. Cu 2 positive. We take copper as Cu2 positive. Okay. When it is not mentioned, then we take copper as Cu2 positive. Okay. You done?
No, sir.
On which you are? You done?
Sir, I am on zinc carbonate F1.
Okay. Mariam, you done?
Yes, sir.
All.
Yes, sir. I did the homework, sir.
Nice. You did the 4, na? You did this in the homework.
Yeah, yes, sir.
Yeah, nice person.
Done, sir.
Done. Okay, let's you check whether it is correct or not. First is calcium
Okay.
hydroxide, that will be CaOH whole twice, plus carbon dioxide will
CO2.
give, yeah, will gives you calcium carbonate CaCO3
CaCO3.
plus water. Next is barium chloride, BaCl2. It will be barium chloride will be BaCl2 because barium has 2 valency and chloride has 1. When react
Yes, sir.
with copper chloride, sorry, when react with potassium sulfate, so potassium sulfate is K2SO4, will gives you aluminium chloride AlCl3 plus copper Cu. When it is written only copper, so we write only copper like this way. Then zinc carbonate, ZnCO3 because they both have 2 valency. Okay, and plus zinc carbonate when react with, sorry, when heated.
Sir,
Yes.
so for the BaCl2, that formula,
Yeah,
the
BA is It is two valency.
Isn't it? Yeah. Isn't it instead of AlCl3? Isn't it? They're asking for barium sulfate.
Oh,
So it's
oh,
BaSO4 then.
actually, I write this one, the above one. So it's okay. That's my mistake here. Okay, no problem. So it is barium sulfate,
BaSO.
BaSO4. Very good. Thank you. And this will be one. So you write it, you will get BaCl2, the formula. Then zinc carbonate, when heated, it will gives you zinc oxide plus carbon dioxide. Okay. Is it so? Yes. Next is what you write here. What you write here? Tell me, Mariam, what you write for the G? What you write for the
Um,
G?
H2.
2 plus
S.
Cl2 gives
Yes.
HCl.
Gives 2HCl. Okay. So you have to keep in mind, these are all unbalanced equations. You have to balance this one and you will learn it how when you keep on practicing. Okay. Okay. Okay.
Yes, sir.
Understood.
Okay, sir.
Now moving to the next part here is that we did this one. Okay. Let's move further. Now, we are just moving towards the exothermic and endothermic reactions. Okay. We will learn the balancing on some other day if you are having doubt in this one. So we'll discuss in some other day. Let's study the new topic. Time is about to, no, time. We have a lot of time. So let's study the exothermic and endothermic reactions. Just so the reaction in which heat is evolved. Okay, is the screen is visible to you? Yeah, it
Yes,
is.
sir.
The reaction in which heat is evolved is considered to be as exothermic reactions. Okay, we called it exothermic reactions in which heat is evolved. If the heat is not evolved or if heat is supplied during the reaction, we considered it as endothermic reactions. Okay, you understood exothermic and endothermic reactions? So
Yes, sir.
note it down, exothermic. The reaction in which heat is released during the reaction is known as exothermic reaction. Okay. Or, just concentrate here one more time. First, let me explain you how the bonds are formed. Like for example, hydrogen gas is reacting with oxygen gas, it will forms water, H2O, two water molecules. So what happens here is that initially the bond between the two hydrogen atoms will break and the two oxygen atoms will break and they will rearrange themselves. The two hydrogen atoms and one oxygen atom, they will rearrange themselves like this way. This is the water molecule. Now here you need to concentrate one thing that since this hydrogen, this is the water molecule and this is the water molecule. Here the new bonds are formed. New bonds are formed. New bonds are formed. Are formed. And here older bonds are broken. Older bonds are broken. So when the new bonds are formed and the older bonds are broken, then it is considered to be as chemical change. But for breaking the bonds, always we require energy. We require energy. Okay. When we are just breaking the bonds, we require energy. And when the new bonds are formed, the energy is released. It is the universal law. When you need to break the bonds, you need to give energy. And when you are when new bonds are formed, it releases energy. But if the amount of energy you give initially to break the bond, like the amount of energy here you are giving 1000 joule, 1000 joule. But here you are getting 1 lakh joule or 1 lakh joule. Okay. So you will say that this type of reaction is known as exothermic reaction because less amount of energy you are giving to break the previous bond and the new bonds are formed, large amount of energy is released. This type of reaction is known as exothermic reaction. You understood? Yes or no? Yes or no? You understood? So what is exothermic reaction? The reaction in which heat supplied is less or energy supplied is less than the energy released during the reaction. Okay, note it down in your copy. You done? Yes or no? Why are you not answering? All have turned off their mics. Mariam?
Done, sir.
No, sir, I didn't finish.
So why are you not answering? Everybody's keeping silent. I was thinking my voice is going to you, not. Note it down. Okay. Now you need to understand one thing here. That whenever in a chemistry, when a chemical reaction is taking place, there is always some system in a surrounding. System is that part in which the observation is taking place, and surrounding is that part in which is around the system, like air, water. For example, if you are doing a experiment in a test tube, then test tube is under your observation. It is a system, and the air around the test tube is considered to be a surroundings. Okay. So in the exothermic reaction, the energy go from system to surrounding. Means the place where the reaction is taking place, the heat goes into the environment, into the surroundings. Okay, like here I've taken the example that this is a test tube, this is a system, and here this circle is known as surrounding. Okay, since the heat is coming or going into the surrounding, we will notice that the surrounding heat is decreasing. Sorry, surrounding heat is increasing and system heat is decreasing. And we focus on the system. If the system heat decreases, then the enthalpy change is considered to be as negative. In chemistry, we considered it as enthalpy change. So the enthalpy change for the exothermic reaction is negative. Why? Because the system energy decreases. Decrease means negative. You can consider it like this way. Okay, so note it down that enthalpy change is negative. And exothermic reactions are called spontaneous reactions and they require initiation energy. One-time initiation energy means, for example, you are burning a matchstick. You just start a one frictional energy, you give some energy and then it will keep on going. Okay, it will keep on going. Why it will be keep on going? Because it is an exothermic reaction, because heat is evolved and all the exothermic reaction keep on going. But for example, if you are passing electricity to the water, to the salty water for electrolysis, the reaction will stop as soon you turn off the switch. So this is known as endothermic reaction. So in the endothermic reaction, they will keep on going unless and until you are just supplying the energy. It will stop when you stop giving the energy. But in the exothermic reaction, it does not happen. It gives the initial energy, it take the initial energy, and then it will be keep on going. For example, if you are burning your magnesium ribbon, it will keep on burning unless and until all the magnesium ribbon get burned. Okay. So this is the way that exothermic reactions are spontaneous in nature and they require one-time initiation energy. Okay, have you drawn this all system and surrounding this way? Drawn this one? Yes or no? Yes or no? Are you
Sir,
there?
one.
Yes, sir.
You're drawing? Yes,
Yes, sir.
Diana, are you doing?
Yes, sir.
Okay, do this one.
Sir, what is after they require one time?
One-time initiation energy means, for example, if you are just burning a magnesium, will it start burning itself? No, you have to start burning it with the help of lighter. Once you ignite it, one-time energy is given, and it will be keep on going. It will not say that you have to let it again after 2 minutes or 3 minutes. If you stop
Yes,
it,
sir.
no, it will be keep on going. It will be keep on burning. No energy is required. It is one-time initiation energy is required. Okay.
Okay, sir.
Like burning of like your mother is cooking food and she's using butane gas. Okay, she's burning hydrocarbon. So does it after 2 minutes you have to let it again? No, unless and until you turn off and then you turn it off again, it will, you need to ignite it again. But It will be keep on burning. The whole cylinder will become empty if she forgot to turn off the uh, burner. Okay, so it will be keep on burning. So because it require one time initiation energy, it will be keep on burning and will produce energy. So unless the whole fuel get exist. Okay, so these are the examples of exothermic reactions, and this is a very popular reactions. Calcium oxide. This is a quicklime. This we called it quicklime. Quicklime when react with water, it will gives you calcium oxide. Okay, calcium hydroxide. The popular the popular exothermic reaction is used in this is the popular reaction and it is used in whitewashing. Whitewashing is what is whitewashing? That you used to paint on your home. That is
Painting.
this yeah whitewashing. So this reaction is used there. Okay. So this calcium oxide when added to water, it produce a large amount of heat. Okay. You do this one, then I'm going to show you that how it produce. This is because this is important. Do this one, then I'm going to show you. Note the example first. Done?